Hello and welcome to PMCD MATHS Teaching, and we're looking at the large, serious topic here of introducing trigonometry. And I'm going to try and do this in two parts, I think, because it's quite a lot to take in one go, if you're doing it properly, in my opinion anyway. Okay, so let's get straight into the rationale here. I'll just put that up and you can pause and have a little read of that. Okay, and I think trigonometry is a classic case of us, when we're teaching this, we think about how are we taught it, and we go perhaps straight into that mode, rather than, I think, being a teacher, really what we should be doing each time is reflecting on, how were we taught it? Do we think that's the best way to teach it? And move on from there, rather than just automatically teaching the way we were taught. So we're just repeating mistakes of well-meaning teachers, but there may be some really good things they do. There might be some things that are not so good that they've done for us. Okay, so as always, my key push on this is for understanding, depth of understanding. And you know what, I get to students of A levels, and they can use trigonometry, they're successful, but you ask to explain what it actually is, and how it actually works, they get stumped. I mean, maybe even us as teachers, if you think about it, do we really know what trigonometry is about? Okay, and obviously there's pressure in class to go on, I need to get through this topic and get to the next topic, but a bit more time taken with the understanding actually gains time later on when you get to more difficult problems, because they can apply themselves in more flexibly. Okay, so I go around here, a bit of an old school approach here, really, with this, because I'm old enough to be at school when before calculators, where you were given tables of results, and this is the sort of approach I go with, because I think the calculator tends to give the image or the impression that trigonometry is something magical. We press these buttons and we get these magical answers, and they give us the answer somehow. And it all adds to that mystery of maths then, which makes pupils feel like they don't quite understand what's going on. And that can affect confidence. So this is the way that I go about it. Right, sequence of teaching. Hopefully I've got all the orders right here. I've got construction of triangles using a protractor, similar triangles. Great if you've done similar triangles, because, as I said, the logical argument here using proportion, you can use that argument from similar triangles. You don't necessarily need similar triangles, I don't think, to actually understand it. But if you've done similar triangles, ideally, I think it means that this all fits into current understanding then. Okay, we're looking really at the introduction to trigonometry today. So I start off with a problem here. Okay, and I'm all about trying to get students to understand that if you're good with mathematics, you're not going to get cold and wet when you can do calculations in the dry, and you can give advice using that method, rather than actually having to go out, for example, to a building site, perhaps, where you've got to measure at the top of a very tall building a vertical beam. So you're putting yourself in danger. It might be cold, it might be wet, not pleasant, and even then your answer might not be that accurate. Okay, so we want to plan the house. How are we going to do this? And this is the problem we're hopefully going to complete by the end of the lesson, or by the end of the first section anyway, of introducing trigonometry. Okay, so I also get them to think about, first of all, what's the angle decreased? What would happen to the height? So if I put 20 degrees in there, and we've got a height, we've got a slant beam there, and I take that slant beam and we rotate it so that, let's try that again. We rotate it, if it's going to let me do this. No, it's not going to do it. Okay, so if we go to 20 degrees, what's going to happen? Okay, what's going to happen here if we go to 20 degrees is, let's try that with a different colour, shall we? A different line then. So 20 degrees might be down to here. What's happened to the height now? Well, we can see the height has decreased, and if it's 50 degrees, the height of that beam would, that upright beam vertical beam would have to increase. If you've got the tools to rotate on your software, then you should be able to use that. And as I said before, this version that I've got here doesn't allow me to do that every time. Okay, so the idea is that there's some relationship between the angles and between these vertical and this long beam here, which I've yet to name here to them as well. And by the way, for us, I wouldn't say this to the students at this stage, but I'm focusing first of all on the ratio, the sine ratio. Okay, so what happens next? Okay, we name the sides first of all of a right angle triangle. So we emphasize that we are using right angle triangles. Good idea again, always to explain what things are. Opposite the angle of interest. Hypotenuse they may have come across from Pythagoras. Usually that's taught before, but it's not necessarily always to teach it before. But hypo means stretched, doesn't it? So it's been stretched over the to make the longest side, and adjacent, English meaning next to the angle. So take time to get some of that literacy in there as well. Makes, it just doesn't cause any buzz or noise in their brains when their heads when they're trying to work things out. Okay, so my first activity. So we're going to come back to that problem later on. This is what I asked them to do. I just asked them to draw 3 right angle triangles with an angle of 30 degrees, measure all the label all the sides, and we're going to abbreviate to op and hype, and we're going to do opposite divided by hypotenuse for each one. We'll see what happens when we divide the opposite by the hypotenuse for each one and write it under the triangle. Now, this whole activity can take, could take half a lesson, could take a whole lesson, depending on how proficient they are at drawing triangles. And you get something about how students actually work. I'll give you an example if they're struggling with that. A right angle triangle, and what I'll do is I'll get my protractor and draw an angle of 30 degrees. I'll do this more accurately than this, obviously. And then they can measure this side and this side. And then they repeat it somewhere else on the page. If they've got squared paper, it makes life much easier. But they don't need to. So what do? I'll put this on the board, actually, results of 30 degrees. And I'll pick students, opposite hypotenuse, opposite divided by hypotenuse. So we're building up a whole set of results for just this 30 degrees. So nice and slowly does it. We're just building it up so that they can understand what's going on here. And, even with the ones that made errors, I don't say, oh no, that's wrong. Just put it up. Let's see what happens. It soon becomes apparent. There'll be enough students or pupils to be able to get the correct answer for you to be able to move on. And we know we're looking for an answer of 0.5. Some will get that, some won't. Some will be very, very close. But if we round to 1 decimal place, we usually end up being quite close there. So it gives them some confidence, actually, that when we divide opposite by hypotenuse, the result is always 0.5. Okay, so and introducing then what this actually means in terms of being able to do questions on this now. We need to understand what that actually means. So what I normally talk about here is I get into the what sine actually means at this stage. So I say, well, look, for a right angled triangle, opposite divided by hypotenuse will always be 0.5 if the angle is 30 degrees. And I said, imagine saying that. That's a real mouthful. I'll try and make it better. A right angled triangle with 30 degrees. When you divide the opposite divided by hypotenuse, the answer is always 0.5. Still a mouthful, isn't it? So what I think it's an Arabic word actually that's come up from here. But if we're looking at opposite divided by hypotenuse, instead of saying a right angled triangle of 30 degrees, a right angled triangle with 30 degrees, when we divide the opposite divided by hypotenuse it's 0.5. We can say equals 0.5, can't we? But to replace all of that long sentence, we can say sine of 30 degrees. I'm going to put this in brackets. And again, this is a function, remember. This is not multiplying, as some students will think it is, means it's multiplying. It means the sine of 30 degrees. It doesn't, not sine times 30 degrees. What does sine mean? Let's put it into words. A right angled triangle. Right angled triangle with an angle of 30 degrees, the opposite divided by hypotenuse. The result is 0.5. Okay. So with a little bit of extension from this, they probably say, well, hold on, is this true for other ratios? So we go back for other sides when we're ready for this. We say, well, yeah, we could have adjacent over hypotenuse. Would that be the same? So this leads us on to the next activity here. So draw triangles to find results for 15, 45, 60, 75, and 90. Now this, again, this whole activity, I think, will take a lesson, maybe a lesson and a half here now. And we're only giving them one go to draw a triangle here. So we're trying to get them pretty more precise with their drawing and get some results. Now, the whole idea of this, as I said, I say to them, about the fact that before calculators, lots and lots of results would have been gathered to get accurate, just like we did that 30 degrees, get accurate results for ratios in a right angle triangle. Okay, when I say ratio, I'm talking about the opposite divided by hypotenuse, or adjacent divided by hypotenuse, opposite divided by adjacent. And those can then be used to solve problems. And so, trust me, you will be able to solve a problem by the end of this, by the time we get to the end of this little bit of study here. And some of them might ask, well, can we do hypotenuse divided by? I say, yeah, we can. We don't do it up to GCSE. We do come across that at A level, but we can come to those. We can at cosec, sec, and cotangent. For higher ability, you might even want to throw that in there. Those are things we can work with. But at GCSE, we're happy with these three here. So get the results, and then, and only then, I'd say, let's get the calculator out and see. So they've had these mysterious buttons on their calculator, not understanding what they mean. And so look, what your calculator's done, and I simplify this, I say your calculator's got a database of results. Now, we know that might be done by approximations for algebraic expansions for sine, cos, and tan, but for their knowledge at this stage, without blowing their minds too much, we can say there's a database of results. So that magic button, all it's doing is telling us for any angle what the value is for sine, for example. Okay, what the value is when we divide the opposite divided by hypotenuse when the angle is 30 degrees, the angle is 45 degrees when the angle is 60 degrees, and so on. And again, they might think, well, why are we going to use this? And say, don't wait, be patient. This is coming. Don't worry. You're going to get the hang of this. Okay. Now, I would say getting to that stage, it's going to take maybe a couple of lessons if you're taking your time with it and you're getting the accuracy there as well. Then we can return to our problem. Okay. So we return to our problem, and here it is. Now, some people might be able to say, I can solve this problem straight away because I know the opposite, in this case, this side here, the opposite divided by the hypotenuse has to be 0.5 or a half. So they might say it's 3 meters. But this is the next thing that I'm very strict on. And I think it's important here when you're working with anything to do with trigonometry, and mathematically generally, is that we don't lapse on what we're expecting in terms of layout. Okay, I've seen some excellent lessons where they've got to the point where the layout, where the teacher's going through the layout, and what happens is they're sort of almost relieved they got through the teaching, and then the layout is rushed, and the students work in a very erratic way, and the next teacher that picks them up the next year or at A level has to then deal with that, and students are often reluctant to let go of that. So we try and get this right. So this is my suggestion of how to do this. What have we got here? We're trying to find the height, aren't we? Let's call it H for height. Okay. And what I do is I always write down, what do we know? Now, this is quite a good idea about any problem. What do we know? Okay, so I say, okay, what's H? Where is H on that triangle? Well, the opposite is H. Anything else? Well, we always know the angle, don't we? The angle is 30 degrees. And what's left is the hypotenuse. Is 6 meters. Okay. And we have to be able to solve a problem from there. Now, before we can do that, what we really need to look at is how to get what the 3 ratios are called here. So I'm just going to move this up here. So what we're going to look at here is the soccer tire, and it's worthwhile, I think, getting them to write this down as well. Now, at this stage, not straight away, this is where I'm actually doing. So this is just an aide de memoire for those 3 ratios. And, sine is opposite over hypotenuse and so on. Okay, so I get them to, I don't like copying, but this is something I think they do need to be able to refer to and know how to spell. What does it tell us? It says sine of the angle is opposite divided by hypotenuse. It tells you what to do once you've decided. Okay, so following this, before we go back to that problem, it's worth, I think, with whiteboards, and this is something that I do quite often, what we do is actually with whiteboards is to practice. I'll say I would like you to identify which ratio we're going to use here. So I'll draw a range of triangles, you know. So I might say, okay, there's X and there's, I don't know, 12 meters, and this is the angle. Okay. What do we know? What ratio would you use? Okay. So we know the opposite, we know the adjacent. I'm going to use tangent. And I would do different triangles in different orientations as well. Okay, because they need to see that. Don't always use the obvious angle either. Okay, so Y and 7 meters, and this is, I don't know, 52 degrees. Okay, so a good little activity here is for them to decide which one they're going to use in this case. Okay, they've got the opposite, the hypotenuse. Okay, I'm going to use sine. Okay, so by the end of this sort of scenario, they should be able to write down what they know and then work out which one it is. So again, at this stage, even on the whiteboards, we know opposite is X, adjacent is 12. Which one of those is? Get them the hang of writing this down. Which one is it? It's going to be tangent, isn't it? Opposite and adjacent, because you've got those two sides involved. So a bit of whiteboard practice with this really helps. And I use this again at the start of the next lesson when we actually go into solving, defining lengths. Let's just get back to this problem now. So what do we know? Opposite and hypotenuse. So write it up again. SOHCAHTOA. This is just an aide-memoire. It's nothing magical. Opposite and hypotenuse. Well, there's opposite and hypotenuse. We know. Well, it has to be sine then, doesn't it? Okay. So I say, now how do we write this down then? So sine of the angle, always sine of the angle, equals opposite divided by hypotenuse. Now sometimes they might struggle to do that straight away, so sometimes I'll just write O over H, and then the next line, until they're happy to go straight to this, opposite is H, and hypotenuse is 6. Maybe a little bit confusing that I've used lowercase h there, so you may want to use a different letter. And then finally, you say, well, okay, well, this is just like an equation now, isn't it? What's stopping h being on its own? If you've done the linear equations, we're going to multiply both sides by 6. So we get 6 times the sine of 30. Okay, is h. Now use the calculator. 6 times sine of 30 is 0.5, and h is equal to 3. Okay, so we've got 3 meters. They haven't had to climb up the building. They haven't had to measure in the howling wind and the rain on a dangerous platform. They've done it all by calculation. Does that make sense? Let's put that in there, 3. Yes, because 3 divided by 6 gives us a half, or 0.5, so it makes sense. Okay, and finally, before moving on to anything else, just making sure everybody's happy with that. So, okay, what would happen? What would happen if this length was not 6 anymore? What would happen if that roof space now needed a beam double the length? So say that was now 12 meters. How high would this have to be now? So it was already 3. How high would it have to be now? And again, it's this thing bringing back similar triangles. Even if they haven't done similar triangles, the direct proportion comes to us quite naturally. If I've doubled the hypotenuse, that means the height is going to be doubled as well. Okay, and if we knew the adjacent, which I haven't measured it here, that adjacent would be doubled as well. What if it was 9 meters? What if it was only up to 9 meters? What's happened there? Well, that's times by 1.5. 3 would be times by 1.5, which would give us 4.5 meters. Okay, so this is the essence of trigonometry. You've got similar triangles. Once you've got a result for one angle, every right angle triangle that has that angle, the results for the ratios, i.e. the opposite divided by hypotenuse, opposite over divided by adjacent, and adjacent divided by hypotenuse will be the same. Okay, and that's quite a lot taken in one lesson. It will take a couple of lessons to get to that stage. And once you've got that, you can keep coming back into testing what trigonometry means. So they don't just get, you try not to get them into a zombie mode where they're actually just pushing calculator buttons. Okay, so following that, we'll go on to part 2. If you watch my video on part 2 now of where to go, so we've done the introduction now. How are we going to apply trigonometry to solve problems? Okay, I hope that you found that useful. I hope that gives you some ideas about, you may adapt that how you want and maybe put things in slightly different order. I found this to be successful, but I hope you found that useful, and hopefully you'll follow on to part 2. I'll see you later.